Hi, I'm Francis Campoy and this is Just for Funk. So yeah, that was me this morning in the gateway of India, beautiful place in Mumbai, where I still am. And as last month, I ended up recording the Flappy Gopher episode number 6 from a hotel room in Paris. This month is again a hotel room, this time in Mumbai. And next month, a hotel room, maybe or maybe not. I hope it will be not a hotel room. I hope I will be back to San Francisco, but who knows? Anyway, if you remember correctly, last month we built a little game. That game was Flappy Gopher. And this month, what we're going to be doing is continuing that video game. Why? Because at the end of the previous episode, which by the way, you have not seen, I recommend watching now. I asked the question, should I continue? And I got so much feedback. Thank you so much, all of you, for giving me so much feedback on yes, you should continue. But especially to the people that actually paid so much attention that discovered that there was a little bug hiding in my code. That is the first thing we're going to be doing today. We're going to be fixing that little data race. And after that, we'll start improving our code until hopefully having a completely fully functional Flappy Bird Gopher game. So let's get started. So I got this message from Tux21B. Thanks for this great episode. Please continue. You have a race in the shutdown logic, by the way. Run differs a bunch of calls that release the resources that are also used by send.run goroutine. You need to make sure to exit from scene.run before freeing those resources. Just sending the cancel request isn't enough, which is true. The simplest solution is probably to run scene.run in the main goroutine and do a gofunc time after 5 time the second cancel or something similar. Optionally using a timer instance to don't leak that. And it could be great if you can support variable frame rates by measuring the time delta between 2 frames. Okay, the variable frame rates, I will probably not do that because it will make my code a little bit more complicated. Unless if someone knows how to do it in a simple way, I'm totally down for that. But let's cover the first part where he talks about a data race. That data race is actually true, and we can see it in action. So if I build my program using go build -race, what I'm doing is I'm actually building a version with the data race detector enabled. And when I run it, we should be able to see the program failing. So let's try to see if that actually happens or not. So if we run our binary, we should be able to see our program running. That is cool. We see the bird flying, and after 5 seconds, the program finishes. Okay, this is not always the case. It doesn't always fail. So let's run it again and see if this time it fails. Okay, so to make this a little bit easier to see why this can fail, I'm gonna fake it and make that loop a little bit slower. Okay. So you see that now it's way slower. And now our program crashed. Good. Okay. So we got it failing finally. Okay. So if we go see it, you're gonna see scene.go line 74. Let's go see that line. Scene.4 line 74 says r.present, and r.present being called from paint, paint's being called from run. Now the problem is that we're calling from run. We keep on running this loop even once context is done because this may take some time. So how do we do it? Well, the best way to do this is to make sure not to call s.destroy, this one here, until s.run has actually exited. That is the problem we have right now, right? So I think that the easiest way is to simply move to this code right here. So we're gonna wait until run returns to return from the run function. This cancel method is gonna be called after 5 seconds. So we could use as Tux21B said, we could write this code. So we're gonna time dot sleep time dot second. So we sleep for 5 seconds and then we call cancel. But actually, this is exactly the same thing as simply calling time after func. We can say after 5 seconds, please call the cancel function. It is exactly the same thing, so we can drop this. Cool. Okay, so let's try to build it again. And this time we're gonna run it with a very, very slow animation, which should cause a data erase if that is the case, if it actually happens. So let's see, let's run it again. We see our Flappy Gopher, our very, very slow Flappy Gopher flying around, and our program finished correctly. So now it looks much better. Now I'd say that the program is indeed fixed. So now that our program is fixed, let's continue and make it better. The next step should be to add gravity and see how the bird falls down. But before we do that, I feel like it is important to do a little bit of a refactoring of our code and see how we can improve it. What I'm going to do is I'm going to add a new type, and that type is going to be the type bird. So we're going to have the scene's going to have a bird. So everything that is related to that type, I'm going to move it to a different file. This is not necessary, but I'm going to move it to a new file because I feel like it. Okay, so we're going to have our type bird, which is a struct that has. So let's try to put those two files one next to the other. So we're gonna move all the textures that we had for the bird in here, and we're gonna call them textures. The time, we're gonna also move it here. Actually, I feel like every single component of the animation should have its own time. So I'm gonna call it here. I'm gonna move it, yeah, I'm gonna call it time too, why not? Okay, what else? We're gonna need to move this part, this initialization part, where we load all the textures. We should move it to a different function here. So we're gonna have a new bird that's gonna return a bird and an error, given an SDL renderer, and it's gonna do pretty much what it was doing here. So all of that stuff is gonna come here, make it a little bit smaller. Okay, so we're gonna call that textures. So that is textures, that is textures. We're gonna call that texture. That is texture, that is texture. And we're gonna return a bird that has time 0 is fine, and texture is gonna be textures and no error. This not very happy with this image. Oh, we need to import that too. Okay, so we have our new bird function. It's gonna return a bird and an error. If that failed, we're gonna return that error. Otherwise, our bird will be bird. Great. Now let's go with run. Run's gonna be the same. We didn't change anything. But when we paint the scene, the painting of the bird, which is all of this part, we're gonna move it to be s.bird.paint. And if error is not nil, we're gonna return that error. Let's define it. So we're gonna have paint, which also requires a render. I'm almost sure I'm mispronouncing that word, but I do not care. We're gonna create a new rectangle. We will have to use that later. We'll have to use the position there, but for now, let's leave it as is. We use s.birds, s.time. That's gonna be actually b.textures and b.time. We're gonna also increase b.time here, b.time, and b.textures. That's the texture we're gonna be copying, and that looks pretty good. Undefined s in birds. I think it's just my compiler being really slow because I'm recording at the same time, so too much memory, which causes my computer to start swapping stuff, and everything is incredibly slow. But it's fine. Don't worry too much about that. Okay, and finally we're gonna have a destroy function that's gonna call destroy for everything, every single texture in the bird. So that's gonna call s.bird.destroy. Great. This complaints because time is evaluated but unused. Oh, time plus plus. And since it compiles, it must probably work. Let's see. Our bird is flapping the wings, and then we finish the program, and everything looks fine. Great. So, what have you done so far? We fixed the data arrays, and then we did nothing. We just moved code around. But now the bird type is way better isolated with just three functions that the scene interacts with. So let's add some stuff to the bird. We're gonna start by making the bird full. So let's see how to do that. What we're gonna need is first know where the bird is currently vertically. So we're gonna add y position. I'm gonna say it's float 64, just so we can have a little bit more of an acceleration later on. But okay, so now that we have that position, when we're painting this, we're gonna use that position right there. Now, if that position is 300, it means that it's right in the middle. The screen is 600 pixels. So if we are in 300, we're in the middle. If we get to 0, I'd like to go to the bottom. So I guess we should do 600 minus this. That is the position. And then we're removing also that 43 divided by 2. So we can center the body of the bird right in the middle. Okay, so we're going to need to use that as in 32, which is the type of the rest. Is that correct? I think it is. And then what we're gonna do is also we're gonna add p.y plus plus, which means that now our bird actually minus minus, and we're gonna start with our bird in position 300. This means that our bird should start right in the middle and start falling slowly. So let's try that. So we compile it, we run it, and cool, we see our bird going down little by little, which is something, you know, not crazy, but we got something working. And now what we can do is, if we want the bird to actually fall, we should have some gravity. So for the gravity, we're gonna need also the speed at which the bird is falling, and we're gonna need a gravity, constant gravity. I'm gonna go with 908 because you know that is the gravity in meters second square, but we'll see if that actually is too much or too little, and we like decide on what to do later. So the position of the bird is gonna change by adding the speed, and the speed is gonna be multiplied by the gravity. So actually we're gonna say minus. So now the speed should be increased, and that's gonna increase way too fast, right? So the speed at the beginning will be 0 though, so speed, wait, if the speed at the beginning is 0 and we have gravity, why do things start falling? Physics is hard. So speed 0, we're actually not multiplying, we're adding gravity. Yes, that is correct. Okay, so we're adding the gravity to the speed, and then the speed to the position. Okay, so speed's gonna be 0 actually, so we do not need to do that. Okay, so let's compile it and run it again and see if now the bird falls faster. And whoa. And the bird's gone. Okay, so let's do one thing and say that if p dot y is less than 0, then we should finish the game, but we will figure that out later. For now, what I'm gonna do is I'm just gonna reset the whole thing. So speed's gonna be 0, and the position's gonna be 300 as the beginning. Let's have lower, way lower gravity. Okay, so run it, and the bird. Okay, so that looks almost like gravity. I'd say that's still a little bit too much. Let's try 0.2. Just half of that. Okay, that looks pretty good. And now to finish, to make it look even better, what I'm gonna do is to make the bird basically bounce on the bottom. So when we get here, the position's gonna be still 0, but the speed's gonna go to minus 50, meaning that it's gonna bounce up. Actually, let's do minus b dot speed. So basically, it's bouncing at the same speed as it arrived. Let's try that. Nice. So we can see now the bird bouncing up and down. Perfect. Okay, great. So the next step we're going to be doing is, rather than having the bird bouncing on the bottom of the screen, we're going to make the bird bounce only when we click or when we tap. So basically, we're going to try to handle the events with SDL2 and see how we do that. Okay, so I actually read the documentation for the library, as we all should. And there's two different functions. There's poll event and there's wait event. And we have, so poll event will pull an event and return something if there's anything, or nil otherwise. Wait event will block until a new event is there. Wait event timeout will wait for a given amount of time. And actually the one that I want to use is wait event. So I'm going to change our code to, rather than sending our context here as we were doing, instead we're going to send a channel of events. And we're going to be polling those events from the main function here. So basically, we don't need that context anymore. Instead, we're going to have a channel of events that I'm going to call is channel of SDL event. And I'm going to pass that events right there. Now, the next step is I'm going to create a new function. And this function, everything's going to do is going to wait for an event and send it to events. That's it. So now what we have is basically that goroutine that is continuously calling WaitEvent, and as soon as it gets an event, sends it to the channel event through the channel event to the run function. Now we need to change this. So instead of receiving a context, now it's going to be events that has a channel of SDL the event. It's a channel that we can only read from, by the way. So we can do that to make sure that our code doesn't do anything weird with it. And then rather than reading from here, we're going to be doing is we're going to be reading from events. Which is gonna log it. Which is gonna log the event that we got with some details so we can see the value, the type, etc. And actually, let's just print the type. That's everything I care about, really. And we're gonna say that is the event, and we're not going to return. Right. So basically, we changed a little bit the code, so we'll be able now to print all the events that we receive. Let's try that. Okay, and if we run it, it crashes. And it crashes with an error. Whoa, that's a long one. Terminating app due to uncaught exception, NS internal inconsistency exception. Reason next event matching mask should only be called from the main thread. Oh, fun. This is one of those libraries that actually make assumptions about what thread does what, which is kind of hard to do in Go. It's actually pretty much impossible, but we can try to fix it. So what we're gonna do is we're gonna move our for loop from that extra Go routine that we had in here in Mendo Go to the main loop and run then this one in a different Go routine. Which should be easy because s.run already starts a new Go routine, so that should not be too hard. Now, on top of that, we're gonna need to call one extra function, but let's not go too fast. Let's start making those changes. So what I'm going to do is I'm going to store that channel, and then here what I want to do is whether I get an event and I send it to the channel, or I receive an error from RC and then I return that. So that is clearly a select statement. So if we receive the channel, then we're done. We don't need to do anything there. But if we get an error from RC, we're gonna return that error, and we close the select statement. Cool. Okay, so that looks pretty good. Let's try to run it. That might work. Spoiler alert, I don't think it does. And it crashed again. But after a couple of events. Look at that. So we printed 2 common events, and then we crashed. And why is this? Well, probably because what happened is that our main Go routine moved to a different thread, which is something that Go routines are completely authorized to do in most cases. In this case, we do not want to do that, but there's a function in the runtime package that does exactly what we want. So we can come here and say that this main Go routine, once we get here, should not move anywhere else. So we can call runtime log os thread. And runtime log os thread, if we go to the documentation, which is right here, you're gonna see that it logs, it wires the calling Go routine to its current operating system thread until the calling Go routine exits or calls unlog os thread. It will always execute in that thread, and no other Go routine can. Which means that now we're blocking a whole thread just to receive events, which I guess is okay, especially because there's no other option, because this library forces us to. But it's fine. Let's see if that now works. Okay, Flappy Gopher, and it's working. Cool. But it's going incredibly slow. Whoa! Look at that. If I move the mouse, which is sending a bunch of events, the animation completely stops. What? We could say that is the game, but that is not the game. And we cannot close it. There's no way to kill it, so we're just gonna kill it with fire or Control-C, same thing. Okay, so why is this happening? Let's see how we're handling that events inside of Scene. What we're doing is waiting for 10 milliseconds, and then either we get an event or we repaint. That is totally wrong, because the problem is that if we receive more than one event every 10 milliseconds, we will always be handling events and never handling that paint. So let's move that. So our ticker, we're gonna call that ticker, or just tick, I guess. And we're going to receive from that ticker. So now what we're doing is we're handling events all the time, and every 10 milliseconds, no matter what, around every 10 milliseconds really, we will call paint. Let's see if that fixes our problem with irresponsive code. Unresponsive? Irresponsive? I'm gonna go with unresponsive, but I'm really not sure. Cool, we run our code, and now no matter how much we click or move the mouse, everything keeps on working at a decent speed, which is exactly what we wanted. Now, if we click here, nothing happens. But we see that we're getting those quit events. So now we can start seeing how our scene is going to handle those events. If we go to scene, we can say, okay, so handle event, s.handleEvent of e. And we're gonna do scene handle event of e stl.event. We're going to do a switch on the type of the event. So you can do that by writing s.type. And let's call this one event and this one e. So now what we have is we have a switch statement where every case is a different type. We're going to have default at the end, and at default we're going to still print a known event event. Otherwise, we're going to be able to say, well, if you get sdl.quit event, as we saw, you should stop the execution. Okay, I guess we could make this return a boolean, and we could do this. So now that boolean basically let us know whenever we're done executing, so we should exit. So we should normally return false, but in this case we return true. Cannot type switch and non-interface. Oh yeah, event.type. So we're checking what is the actual type of the event that we received. If it's quit event, we actually exit, so we return true, and which will set done. That is so bad. Var done is false, and we set done to this. So as soon as done comes true, we actually exit the loop. Or if done is that and we are done, then we could return. It's maybe better, it's simpler to follow. Okay, so E is declared and not used. That is indeed the case. So let's not use it for now. We will use it later, but for now let's just leave it like as this. Cool. Let's test this. So now normally if we click on the X arrow, what am I saying? In the red X, we should exit the execution of the program. Okay, so Flappy Gopher, this is bouncing, we click here, and the program exits. Nice. Okay, so that looks pretty good. What else can we do? Let's make our bird actually jump whenever we tap. So let's run it again and see what happens when I tap. There's a touch finger event, mouse button event. I'd say it's mouse button event probably. The others, I think it's just the mouse going a little bit crazy. So let's try with mouse. I lost it. Mouse button event. So mouse button event. So now we can actually access E is of type SDL.mouse button event in that branch, which is pretty nice. So we can access directly the concrete types. So I don't care what button is pressed. I'm just gonna make the bird bounce. So let's change s.bird.speed equals let's say -10. Actually, let's let the bird decide on that. It's called s.bird.jump, and we're going to define that new function. So we're still not using the E, and we're gonna go to bird. We're gonna define our, let's define it here. Let's define it here at the end. So we can jump, and that will make our speed go to -10. Let's say, yeah, to 10, so it goes up again. Cool. And now we can actually let's keep that for a minute. Let's keep that so it will rebounce if it gets to the bottom. Otherwise, we might lose it. Whoops. Line 64, we're missing a return. Oh, yeah. What are we returning here? We're returning false. We're not done yet. We're going to be actually returning false for every single one except for this one. So let's move the return at the bottom to the bottom. Okay. So if we tap out, I actually got the wrong direction, but you can see that we're actually bouncing. So let's just change our bird to say it's jumping up. So if we compound, we run it again. Now we should have something that starts to look really like the game, except that there's no pipes. But we'll work on that in a minute. I guess it works. But I think that if you click twice, it's actually taken into account as a different thing. Motion event. Okay, so let's ignore this one. I don't want to see all of those events because there's too many of those. So if that is one of them, don't do anything. We don't care about motion event. We don't care about window event either. And that's it. That's all the ones. So we can now basically those will not be printed anymore, which will make our logs easier to follow, to understand what are the events that are getting fired when we click on stuff. Let's run the game. We jump once and it works. Whoops, I jumped too far. That actually works. And jump again. Boom. Now it's bouncing very high, so we see that we're getting a touch finger event. That is when we're actually tapping, not clicking. We could... No, let's just ignore that too. Okay, so one last thing that I want to change is I feel like that is jumping a little bit too high. So let's do 5. And you need to take into account that this will actually change. Like, actually, well, let's move it to jump speed. So basically, we're gonna have another constant here. Jump speed equals 5. Which playing with the gravity and the jump speed, we're gonna be able to change how the game behaves, basically. So let's run this. Cool. I like this one better. You can basically control a little bit more, decide when it goes up and down. Cool. And then click here and we're done. Okay, so it might seem crazy, but this video has been going on already for over half an hour, which is the limit I'm trying to impose to myself. So I'm gonna stop it here, and we still do not have pipes going on, but I think that all the part about how to manage different events and how to play with the goroutines and the channels, how to log goroutines to threads whenever it's needed by C++ libraries and stuff like that was, although hard, pretty interesting. I hope you liked it, and I will continue with this episode in 2 weeks. I decided that 1 month was a little bit too much. I'm still trying to basically figure out how long is too long and how short too short. 1 week is definitely too short. 1 month is a little bit too long. So expect having this next episode with Flappy Gophers and pipes that will make them crash in around 2 weeks. That will be in March. Yes, March 15th. Let me know if there's anything that is wrong, if there's a bug. Thank you so much for that bug report from before. I really appreciate. Let me know if you like this. Let me know if there's any other topic that you'd be interested on me covering. Or also, if there's any code that you'd like me to review. I'm also looking for more code to do a third code review episode. So if you have some code that is not too long, not too short, not too complicated, but not too simple, and you think it might be an interesting topic of conversation for me, send it my way. Well, see you all in 2 weeks, and as always, thanks for watching.